work on AI-driven fertilizer optimization for wheat yield. So today I will be explaining the introduction followed by the objectives and the problem statement. So let us begin with the introduction of our project. Before moving to the technical part, let us I would like to mark some of the challenges which has been faced by the farmers during the cultivation. So farmers will be struggling to find what is the right amount of the fertilizer should be provided for the cultivation of the wheat. So sometimes overuse or underuse of the fertilizers may lead to the degradation of the soil, or it may decrease the long-term productivity, or it may directly affect the economic status of the farmers. So our project helps to resolve all these problems. By using AI, we can provide precise and customized fertilizer recommendation using the soil data. As we all know that in our model, it will based on the soil parameters like nitrogen, phosphorus, potassium, pH, and the organic carbon values. Our project help us to determine the precise fertilizer recommendation using the soil data. As we all know that agriculture is one of the most nutrient dependent industries. For achieving the higher yield, overuse or underuse of the fertilizer may lead to the decrease of the soil fertility, and it may decrease the low productivity, and also it may lead to the economic loss of the farmers. So sustainable management is very essential during the wheat cultivation. So in our project, we have developed an AI-powered fertilizer optimizer, which is trained by 1,000 sets of samples on the Davangere KVK soil, so that based on those samples, it will precise the fertilizer recommendation to the customers or the farmers. So this is about the simple and the brief explanation of our project. Next, we will move to the problem statement of our project. As I already said that farmers only rely on the manual or the experience-based fertilizer application. So this results in the excessive use of nitrogen, phosphorus, and the potassium. As the fertilizer contains these three components such as nitrogen, phosphorus, and the potassium, excessive use of these three components may lead to the soil may lead to the degradation of the soil, or we can say that it may reduce the soil fertility, or it may increase the cost of the cultivation for the farmers, or it may lead to the low nutrient efficiency. To resolve these problems, we need a system which provide accurate data-driven crop-specific fertilizer dosage wheat based on the soil parameters. Means we need a system based on the parameters we provide that must provide a precise fertilizer dosage for the wheat cultivation. So this is about the problem statement. Next, we will move to the objectives part. In our project, we have 5 main objectives. That is, first one is to design an intelligent system that predicts optimal fertilizer dosage of wheat. Means we in our project we have designed an AI system which will predict an optimal fertilizer dosage for the wheat cultivation. And the next objective is to build a random forest based ML model for predicting a urea, SSP, and MOP requirements. Means here in our project we have built an machine learning model for predicting the components such as urea, SSP, and MOP requirements, so that the good amount of the fertilizer will be provided to the wheat cultivation. And next objective is we have used the SHARP for explainability and transparency in the fertilizer recommendation. SHARP means it's a shapely additive explanation. Means it is a method to explain what are the parameters we have provided, and what will be the output, and what will be the predicted fertilizer for the wheat cultivation. It will help in that transparency for fertilizer recommendation. And next is we have implemented a user-friendly streamlined web app for real-time fertilizer suggestion. And the last objective is we have to promote the sustainable agriculture through precise nutrient management. Means here we have the main objective to promote the sustainable agriculture for the nutrient management. Next part will be continued by Sanjana.
Good evening, sir. I am Sanjana. Now I'll explain the literature survey, which highlights the key research works related to the fertilizer optimization and smart agriculture. Firstly, the author is Singh et al. In 2020, this study focused on AI AI-based fertilizer recommendation for cereals. They compared the machine learning models like random forest and SVM, means support vector machine. The key result is the random forest performed better for a nutrient prediction. The methods they used is the random forest and SVM. Mina et al. In 2019, this work looked at the fertilizer optimization for wheat using agronomic models. They provided the generic fertilizer advisories for northern India. The method they used is a traditional soil test-based approach. Then Sharma et al. In 2022, this study used SHAP with the gradient boosting to make the agricultural machine learning models more interpretable. The key findings are the SHAP improved the transparency in the nutrient prediction. The method they used is SHAP with the gradient boosting. Liu et al. In 2020, they developed the multi-output machine learning models to predict the multiple soil nutrient at once. The key findings are the high accuracy for predicting the nitrogen, potassium, and phosphorus together. The method they used is a multi-output random forest. Overall, the past research shows that both the machine learning methods and the traditional methods helps to improve the fertilizer planning for the better growth of crops. Next, the system requirements. The system requirements for implementing the project includes both the software and hardware components. The software requirement includes the main tools and libraries used for the development of data processing, model training, and visualization. Firstly, the Python 3.10 plus. Here it is the core programming language which is used for building the models. Streamlit, it is used to develop the interactive user interface. Pandas and NumPy, it is used for data cleaning and numerical computations. The scikit-learn, it is used for machine learning. It is used for training and evolution of machine learning models. Matplotlib, it is used for plotting the graphs and visualization of results. SHAP is used to make the model interpretable by showing the feature importance. The joblib, it is used for saving and loading the trained machine learning models effectively. The hardware components are 8 GB RAM 2 plus that ensures the stable.
Can you repeat SHAP?
Sir?
SHAP. What is SHAP? SHAP.
Shapely additive explanations.
What it does? What it for?
It selects the it shows that the features that are more that shows the prediction. The features that shows the prediction. That shows the predicted values.
Okay, continue.
The hardware components are 8 GB RAM, 8 GB RAM 2 plus. It ensures the stable training and machine learning models. The core CPU, it is required for faster processing and handling the data sets. Local PC or cloud hosting. The project can run either on the personal computers or with the cloud platforms for deployment. These specifications helps to maintain the performance and ensures the applications runs without lag. The data set for the project, we used the real world soil data set collected from the Davangere KVK. The dataset file used is the final Davangere KVK 1000 rows.csv. It contains this 1000 soil samples with important nutrient attributes. The dataset contains the following key attributes that are the soil n kg per hectare. This represents the nitrogen contains the nitrogen content in the soil measured in the kilos per hectare. The nitrogen supports the plant growth and leaf development. Soil P kg per hectare. It means the phosphorus level in the soil. It helps in root growth and energy transfer. Soil K kg per hectare. This includes the potassium content in the soil that is measured in kgs per hectare. The potassium improves the plant strength and disease resistant. The soil pH, this tells how acidic the soil is. The pH affects the nutrient absorption by plants. Urea kg per hectare per acre. This is the amount of urea fertilizer that is needed for plants per acre. Urea provides the nitrogen to the soil. SSP kg per acre. This is the required SSP per acre. SSP is the source of phosphorus. MOP kg per acre. This represents the amount of MOP that is required for 1 acre. It is the major source of MOP is the major source of potassium. MOP represents the muriate of potash, and SSP is the single source phosphate.
Now let me explain about the methodology. We started our work by collecting 1,000 data samples from Davangere KVK. Each sample contained 4 major important features, which are nitrogen, phosphorus, potassium, and pH. After collecting the data, we performed data processing. This includes handling missing values and applying scaling where the required to make the machine model more stable. Now, we selected NPK and pH as our important source because they directly influence on the fertilizer requirements. For predicted model, we used random forest regressor. We choose random forest regressor because it works well with non-linear data and give accurate and supports multi-output prediction. This is most important for us because we needed to predict 3 fertilizers, urea, SSP, and MOP together. For training and evaluation, we used an 80/20 train test split. 80/20 means 80 for training and 20 for testing. Next, to understand why the model gives us the particular prediction, we use SHARP explainability. SHARP helped us to see how these soil features affect on the output. Now let us go through the implementation of our project. We implemented our system using 3 random forest models, one for urea, one for SSP, and one for MOP. These fertilizers represent nitrogen, phosphorus, and potassium. After training the models, we saved them in a single file called Best Fertilizer Model PKL. This allows us to load the model easily during the deployment. For user interface, we built a modern light-themed Streamlit web app. In this, users can input their soil, nitrogen, potassium, and pH values and get the fertilizer optimization values. Now let us go through the results and discussion. Finally, the random forest model achieved a R-square value around 0.956, showing very strong predictive performance. This means our model can estimate fertilizer requirements with very high accuracy. From SHARP analysis, we observed that nitrogen has biggest impact on urea prediction, phosphorus strongly affect SSP, and potassium influences MOP. Our application provides fast and accurate fertilizer recommendation, helps to reduce cost, prevents user usage for fertilizers, and support best crop yielding. Thank you.
Good evening, sir. I am Vilasini. I am here to explain about the conclusion of our project. In the project, we created an AI tool that helps the farmers to know the correct amount of fertilizer needed for wheat. And the system looked at the soil nitrogen, phosphorus, potash, and the pH value and gives the exact urea, SSP, and the MOP required. Our model is very accurate. So farmer doesn't have to guess the fertilizer quantity. This prevents using too much or the too little fertilizer, saves the money honey and prevent the keeps the soil healthy. Using sharp, we also show why the model gives the particular recommendation. So the results are clear and easy to understand. And next we go to the future work. In the future, we want to improve our system in many ways. First, we want to add the wheat yield prediction along with the fertilizer suggestion. And the next, we plan to connect to IoT sensor so the soil data can be collected automatically. And we will also expand our model to the other crops like ragi, rice, etc. And another improvement is to include the weather-based advice such as a rainfall and the temperature. Finally, we aim to make make a mobile app so the farmer can easily use this tool on their mobile phones. And next we go to the application. Our system can be used in many places like agricultural universities and KVK centers can use it for teaching and the research. And soil testing labs can use it to automatically suggest the fertilizer instead of doing manually. And it can also be used in smart farming and the precision agricultural tools. Government scheme can use this system to give the better fertilizer advice to the farmers. And finally, it can be made into the mobile app so the farmer can quickly get a fertilizer suggestion. And next we are going to the reference. For our project, we use the several important reference. We use the Davangere KVK soil dataset from 2024, and we refer to the sharp research paper by the Landberg and the Lake to understand the model explainability. And we use the documentation from the Learn for machine learning and the Streamlit for building our app. And we also looked at the research paper like a AI-based fertilizer recommendation system. And finally, we studied the paper on wheat nutrient management and decision support system. Thank you.
Screen sharing stop.
Okay. Your presentation is very nice. All of you have done well, but somewhere the main technical aspect is missing. Nowhere you are talking about the technical or algorithm. Can anybody explain algorithm or how the things are going to happen here? That part is missing. Technical part is missing in your presentation.
Okay, sir. Sir, here first we took a random forest model in which we used three submodels called urea prediction model, SSP model, and MOP model. They will analyze the input data and give the correct output data based on the sharp explainability, sir.
That's what that model you have to explain how that model works. Any one model you can explain, right?
For example,
other model you explain Boda.
Sir, for example, urea prediction model, if we have very much of nitrogen based on the input value, it will analyze based on the data set and give predicted value by using sharp technologies, sir, which are inbuilt and give the expected.
No, that's what I'm asking. How it works? There should be some technical thing, or there should be some technology or algorithm, or there is a something which how it will predict. Simply, it will not predict, right? It may use some formula, or it may use some steps, or it may use some assumption. So something should be there. How your random forest algorithm works, or how your models are working, at least any one model you could have explained that could be better. Okay, every time you are talking about sharp, what is that sharp, SHAP?
Sir, let me show you that sharp technology. Sir, here is that feature impact distribution and the sharp technology of urea production, sir. For example, if we take urea production, we have sharp values such as 1, 2, 3, 4, 5, 6 based on the impact on model output magnitude, and we have several contents such as nitrogen, potassium, soil pH, and phosphorus. Here the nitrogen content must be high, and if here the red clusters are showing towards the negative sharp values, and more blue clusters are showing towards the positive sharp values. If the red clusters are below 0, then we have high value of nitrogen, so we have to apply low urea in that fertilizer. And if we have uh, low nitrogen value in that fertilizer, means we have to add high amount of nitrogen in that urea. Based on this, the model will impact the outputs.
Okay. Now, how do you calculate this value, sharp value? Okay, if you come across the red one, you have to add nitrogen. If you come across the blue one, you have to add nitrogen. If you come across the red one, then you are telling that so it is not, you have to reduce it, right? But how do you get this value? How do you get negative value, sharp value? How do you get positive sharp value?
Sir, based on the input amount of nitrogen, potassium, and pH values, sir.
You take one example and explain how the sharp value will, you are going to calculate, or how that will be automatically your model is going to work. Okay, it is automatic. I know there are some models are built-in models. You are used that, and it will automatically shows the value. But you should know how that algorithm works. For example, you are talking about support vector machine. Then how that algorithm works? KNN method. How that KNN algorithm works. So like that, you should know how that algorithm works. That is my concern, right? So
Sir,
whatever you have done, it's not wrong, it's correct, but my concern is you have to learn the technology behind that.
sir,
That
it
is
has
what the difference
some.
between the computer science student and the other students. Yes, you are telling something, huh?
Yes, sir. If it has some formula, sir, uh, to calculate the amount of nitrogen, we have to take the uh, pK value and NPK values and minus that NPK minus pK value, so that we can get the nitrogen value based on the sharp technology. For example, if we have phosphate and potassium values as 30, and nitrogen, potassium, and phosphate values as 45, by applying that into that implemented model, we get the contribution of nitrogen as 15, that is 45 minus 30, sir. So the final average is the sharp value, that is the feature, and it is repeated in every function.
That's what you have to put that formula, and you have to explain with an example. That's the one thing. And where, in which paper, which IEEE paper, some you have given references, no? In which paper you have taken that formula, or who has given that, whether it is available in the textbook or it is available in the internet, where it is available, how you have calculated, where is that formula, how, where, from where you have taken, at least that you have to tell. Then it becomes what more more weightage will be given to your mini project.
Yes, sir. The
Okay.
formula is
You are talking about pre-processing. What you have done pre-processing? Now you have told about something you have done missing value pre-processing. How do you handle the missing values in your
yes, sir.
pre-processing technique?
If we have given n nitrogen, potassium, and soil pH, but we are missing with phosphorus, then then by taking that data set which is predefined, so we can adjust the values based on the data set, and the model is trained based on that values, sir. If any one
No,
value is missing, it can adjust and give the.
I'm asking you, give me one example.
Sir,
No,
audio is
give me
not
one example how you have handled the missing value. Suppose do that. How do you handle it?
sir.
I think now I'm getting proper audio and video both.
Yes,
Am I audible now?
yes, sir.
Yeah. So my question is, how you handled the missing values when you are going for the pre-processing? Suppose example, suppose potassium value is missing in your table. How you have done the pre-processing? Which technique you have used? Am I audible?
Yes, sir.
Yeah. Have you got my question?
Yes, sir.
Yeah. You explain. Give me the answer. If you know, you can tell. Otherwise, say no. You don't know. It's no issues.
No, I don't know, sir.
You don't know, right? Okay. In the coming days, whenever you, because it is a problem with every student. Even we lecturers also will feel the same thing. Whenever we are using the built-in functions, we should know how to do it. You have mentioned there. That's why I'm asking. So when you have mentioned in the implementation step, so you should know how you have done the pre-processing, which technique you are using, and at least you could be able to explain if that is missing, how you can handle. Suppose you have a database and there is a one person age is missing, right? So what you will do, so what we do is, usually if the age is missing, then we will take the average of all the members present in the database, average of the age, and that value will put it there, right? So that is one way of handling the things. And suppose it is year is missing, say 2024 or 2025. So which is highest, which is appearing more number of times, that value will put. So something like that we will do the missing handlings in a pre-processing. So that type of techniques you should know when you are doing for the pre-process of the data. So that is other thing, but you should know at this time, in the fifth, sixth semester, or in the fifth semester, you should know what is pre-processing, so that you can do more things in the coming days. Okay. Otherwise, the whole presentation was good. um, and the output is also getting good, and you can improvise this as you have told in your future work. You can improvise this and you can implement in a mobile app in coming days. That will be better. Okay. Okay. Anything else you wanted to discuss?
Yes, sir. We also included the chatbot, sir, about the app units, a data set, or simple
Yeah.
fertilizer questions, sir.
Okay. Fine. It's good. Which API you have used for this?
Sir.
Which API you have used for this? Okay. If you don't know it and tell me in the next day. Monday the ನೋಡ್ಕೊಂಡ್ ಬಂದು ಹೇಳಿ ಯಾವ API ಯೂಸ್
For
ಮಾಡ್ಕೊಂಡು ಈ
that,
ಚಾಟ್ ಬಾಟ್ ನ ಇಂಪ್ಲಿಮೆಂಟ್.
for any chatbot, we use Flask API, sir.
Okay. Which package import? You have to import something, and then in that you have to call a one particular function or some API, right?
Sir.
Mhm. So that you know, understand it and explain me tomorrow, Monday or Tuesday. Okay, all the best. You have done well. We will see in the future days you can do better than this project, right? Okay, thank you.
Thank you, sir.